Welcome back to, hopefully, the last part of these notes. We are going to be doing a couple of things. It says it all right here. It says to find the inverse, graph the original function and the inverse function, see if it's a function at all, and determine the domain and range for both the original and the inverse for these. So first things first, I'm going to be doing this in two colors. Blue for the original, and then red for my inverse, whatever it may be, just so you can kind of get an idea of what's going on. I recommend always graphing this first. It makes doing the inverse a lot easier, especially if it turns out to not be a function or something. But this right here, 2x minus 4, is a line. The very first unit we did of this year was graphing lines, so hopefully you remember slope-intercept form, where you start at minus 4, that's 4 I believe, 1, 2, 3, 4. Yep, minus 4. And then the slope is 2. So you go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc. And I just said I was going to do this in blue and started doing it in red anyway. Woo! There we go. So that is the original function right there. Note that I don't even have to find the inverse function in order to draw the inverse, because one of the things we talked about was that if you have a graph, you can find the inverse by taking all of the ordered pairs right here and switching the x and the y and replotting them. For example, if this is 2, 0, 2, 0, you can plot 0, 2. This looks to be 3, 2. So instead of 3, 2, you do 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. So instead of 4, 4, you can do, 4, 4. And you get the same thing again. This would be 1, negative 2. So negative 2, 1. And you can kind of see this is starting to form a line too, like so. And you could connect that. And congratulations, before you even know what the inverse is, you know what it looks like. And I would just be done with this graph already. It's just a lot easier to do that way. You're less likely to make a mistake when it comes to graphing whatever turns out to be here. So I always do that part first. Once again, it's just you take some ordered pairs and you switch them. To actually find the inverse, though, that's the whole make it x equals 2y minus 4. So instead of x, put a y. And you would solve for x. Like that. And then to get y by itself, you would divide by 2. Those would go away, and you would get x plus 4 over 2 equals y. This is, of course, correct. That is the answer. Most people don't write it like that, but if you put this here, that would be correct. It's just, if you look at this and you look at this line, you would probably be like, huh? How is this fraction thingy going to be there? And the answer, you're going to love this. You use the heart technique, as I call it. Basically, if this is a 1x over 2, you could make it a 1/2 x. Right, 1 over 2, 1/2. And then 4 divided by 2 is 2. So you would get 1/2 x plus 2, which is the equation of a line. Plus 2 is the y-intercept. Da-ding. And the slope is 1/2, so up 1 and over 2. Cha-ching, cha-ching, cha-ching. Money. And there you go. It all matches. Is it a function? Well, it passes the vertical and horizontal line test, so yes. So once again, horizontal and vertical line tests. That's how you can tell. Domain, it goes left forever and right forever, so negative infinity to infinity. The range goes down forever and up forever, so also be negative infinity to infinity. And similar reasoning for this one, it's going to be the same thing. And if you're getting lazy, you can just use all real numbers. And by lazy, I mean efficient, yes. On the next one, we now have square root 1. which if you don't know how to graph square root, I suppose worst case scenario you can plug it into a calculator and then use the table to get some points. Or if you know your perfect squares pretty well, you can plug in some numbers. But I'm going to assume the worst. You go here, you type in square root x plus 3, and you can look at the graph just to kind of get a feel of what it's supposed to look like. It's this little curve starting a bit on the left, but definitely make sure you are looking at the table to get some actual whole numbers. Don't use these decimals. Why in the world would you use those decimals? Bunch of errors, so let's start with -3, 0. Boom, boom, boom. -2, 1. Skip a few. 1, 2. Any others? 6, 3. 1, 2, 3, 4, 5, 6, 3. Yeah, and that's all that's going to be able to fit. So there we go. And as I said, you can just go ahead and draw the inverse right now. We said it was -3, 0, -2, 1, 1, 2, and 6, 3. So the inverses, you would switch the two numbers. Instead of -3, 0, it'd be 0, -3. Instead of -2, 1, 1, -2. 2, 1, 3, 6. And you would graph those points. So 0, 1, 2, -3, 1, -2, 2, 1, and 3, 6. Like that. And they look like inverses. They reflect across that diagonal. So it's good to go. This is one of the cases where when you find the equation here, you will most likely get it wrong if you start to graph this, especially if you're using a calculator. If you find the inverse algebraically and you plug in your calculator, it is not going to look like this, and that is due to the domain restrictions that we talked about in the previous video. If you remember, there are domain restrictions in two cases, fractions and square roots. And guess what? This is a square root. It will have a restricted domain, which is why it's not going to look the same when you do it. So I always graph it first. To actually find the inverse, though, you'll have x equals the square root of y plus 3. You will square both sides and get y plus 3. All right. So x equals square root of y plus 3. Square both sides. Subtract 3. And y is now by itself. So you get x squared minus 3, like that. Is it a function? It passes the vertical line test. It passes the horizontal line test. So yes. Yes, it is, in fact. And I'm just going to prove to you that I'm smart. I'm going to plug in x squared and show you that it is not right. As I told you, it would not be right. Bam. And oh, snap, that's right. It turns out that what you get here does not match the actual inverse because it's only supposed to be that half right there. Because of the restricted domain, it's the graph that's drawn here, but it's only the positive side, right? Because over here is positive. So it matches, but both does not match because that is not supposed to be there. Domain of the one in blue, it starts at -3, including -3, and goes to infinity. The range, the lowest is 0, and then it goes up to infinity. And the cool thing about inverses, if I told you before, like I think this was 2 videos ago now, is that if you have an x and a y, for the inverse, you switch the x and the y's. With domain and range, domain is x, range is y. So if you're doing the inverse and you switch the x and the y, it turns out that these will always interchange. 100% of the time, no exceptions. The domain of one becomes the range of the other one. So if you get these, you can just flippy-floppy them in order to get the answer there. And that's it. That's how you do these problems. I'll go through, what was it, there's 3 more. Yeah, I'll go through them. Maybe I'll put the answer key for you guys to look at. I'll walk through one more, but then the other two will just be up on an answer key. So here we go. X squared looks like this. Boop, 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 boop. Huzzah. And I accidentally did the original in red this time instead of blue. If I wanted to do the inverse, then you'd have 0, 0. And instead of 1, 1, I would have 1, 1. Ooh, okay. Negative 1, 1 would now be a 1, negative 1. 2, 1, 2, 3, 4. So 2, 4 would now be 4, 2. So 1, 2, 3, 4, 1, 2. And this is negative 2, 4. So I would do 4, negative 2. And it's going to make this kind of U shape going that way. So the inverse is now drawn. If I make this an x equals y squared, then I would need to square root both sides, and you would get y equals the square root of x, sort of. Because, once again, please don't forget, whenever you square root both sides, you do need to put a plus or minus in front. So it would be plus or minus x. Do keep in mind, as soon as we get to this part of the question, is f inverse a function? Well, it does not pass the horizontal line test. So this one is not actually a function. That is plainly obvious with the plus or minus here. This is actually two functions in one. There's the positive version of x squared and the negative version of x squared. So like, you can't just do, oh, I'm going to press the plus and minus button in a calculator. You can't. It doesn't work like that. You can, however, do the square root of x right here, and if you graph it, you'll see that you get this top portion right there. And then if in a different line you type in the negative square root of x, that fills in the rest to make it have the other portion of it. So it is the plus and the minus put together that makes this u going to the other side. In terms of domain and range, this will be all real numbers because it's going left forever and right forever, which then means this one also has to be all real numbers. The range for the red one starts at 0 and goes up forever, which means this one is also going to have to be that. But you can always double check. Domain of the inverse, the domain starts at 0 and goes to infinity. So yeah, it's good. Cha-ching. And there you go. As I said, I'm going to give you the answers to the other ones. I think I have them just right here, so feel free to take still images. Just pause it if you want to look at it any more than it is. So go ahead, pause it if need be. And oh boy, it looks like I have a lot of work on this one. So pause if need be. I'll zoom up on the little parts of it. It looks like I have this for the answers, for the work, down there. Okay, have a good one. Hopefully this helped. Take care.